Hello everyone, good morning and welcome to our, today's webinar, Stop Poor Requirements from Inhibiting the Success of Your Projects. My name is Jose Muñoz and I am a Senior Requirement Consultant in Visual Solution. During today's webinar, we will be discussing some of the key aspects, some of the main reasons for projects failures nowadays in both system engineering and software engineering world. And we will be analyzing how good quality in our requirements can help us to skip those or to avoid those failures. Before starting with the webinar, I would like to describe to all of you the GoToWebinar interface. During the following webinar, all of you will be mute, but you can use the GoToWebinar interface, the GoToWebinar tab, in order to post any question that you may have. At the end of the webinar, we will have time for a Q&A section in which we will be answering all those questions. Additionally, I will be recording this webinar and you will have access to this recorded webinar afterward. I think that's all for the presentation, so let's move forward and let's start with today's webinar agenda. The first point in today's webinar is going to be describing Visual Solution, our company. It's going to be a short introduction, just a couple of slides, and after that we will be moving to the main topic of this webinar. What's the problem with the current development projects? We will be analyzing those problems and we will be linking all of those problems with poor requirements. After that, we will be moving forward to the different techniques and different mechanisms for writing good requirements. For helping us in this task, we will be introducing the Visual Quality Analyzer. This tool is going to help us to improve the quality of our requirement based on certain predefined rules that we can customize, that we can tailor to our specific project. We will be able to get some metrics about our requirements quality and also get some tips and some hints for improving the quality of those requirements. Afterward, we will be having also a short demonstration of this tool, of the Visual Quality Analyzer, also with the help of the Visual Requirements tool. I won't be focusing on visual requirements because this is not a visual requirement webinar, but we will be watching some of the capabilities in the tool that will help us to improve the quality of our requirement. To finalize, there will be some conclusions and also some time for the question and answers. As I just mentioned, remember that you can post your question during any time, and at any time during the webinar you can post the question and I will be answering all of them at the end of the webinar. So let's move forward and let's start with the first point in our agenda, which is going to be Visual Solutions, the requirements company. Visual, our company, is a company specialized in both requirements engineering for system engineering and for software engineering companies. Requirements are everywhere, not just in software but also in systems. So we pick the best of both worlds and implement that into our tool. We are manufacturers and distributors of Visual Requirement, our leading requirement solution that you will be watching in the webinar after this short presentation. But additionally, we also offer different services, training, consultancy, all around requirements. As you can see here, we are ISO SPICE certified and we also are IREP certified, helping also other companies to get certification for the IREP. Finally, our headquarters are located in San Francisco in the United States of America, with different offices in the United Kingdom, Spain and Germany. Here in this slide, you can also see some of our main customers worldwide. As you can check in this slide, we have got customers in both worlds. Software engineering, for example, banking, telecommunications, and also in the system engineering world, like automotive, rail, aerospace, defense, and so on and so on. The next point in our agenda, in our webinar, was the main reason for project failures nowadays. We have been watching, we have been analyzing, we have been seeing an increase in project complexity, not only in software projects but also in system engineering projects. As you can see in this chart, we are measuring projects in millions of lines of code, and we have moved from like 3 million lines of code in 2006 to more than 50,000 millions of codes in 2012. Basically nowadays, users are asking for much more features, much more quality in our projects, and that is going to impact in the requirements and in the project development. Okay, as you can see also in this slide, the number of requirements is also huge for the different projects, going from 40,000 requirements in the medical device system to more than 1 million requirements into an aircraft carrier. This means that basically nowadays we are adding more and more features to our projects with thousands or even millions of requirements that are going to impact into all these steps of the development. So we have to expend some extra time with those requirements, making sure that, or ensuring that everyone is going to understand those requirements and everyone is going to work with the same set of requirements, with the same information. Additionally, we have been also watching, we have been beholding a disconnection between the business and the development. Okay, usually what the business need or what the business is demanding is not what we at the end we finish developing. In fact, less than 50% of the requirements go into production, and also 3% of those requirements become obsolete per month. At the end, what we finish implementing or what we finish deploying is really far away from what it was initially planned. Okay, this means that the requirements are going to change through the project lifecycle, and that changes are going to impact to the whole project. So we have to somehow be prepared to adapt to those changes, to fit into those changes. So we have to somehow write the requirements in a way that is going to be easier to be prepared for those changes. Finally, well, not finally, but another important fact is that the reasons for failures in our project are, of course, different reasons, but one of the main reasons for project failure it's related with the requirement. As you can see in this chart from James Martin and Barry Bohem, 56% of software defects are trackable back to poor requirements definition and management practices. There are, of course, other reasons like problems or bugs in the design, problems with the codification, other problems. But the main reason of failure is related with the requirements. Poor requirements, bad requirement, changes requirement that we weren't able to manage properly, and so on and so on. Not only that, but also we have to take into account the cost that a failure in the requirement is going to have into the final project. In this chart here, we can analyze the fixing cost of a requirement, the relative cost of correcting a defect in the requirements step. So let's picture that we are in the requirements step, we are gathering the requirements, or we are working with the requirements in our project, and we detect a failure in one of those requirements. Okay, so let's also picture that the cost for fixing that failure is going to be $1, for example. Okay, it's going to be pretty cheap because we are still writing the requirements. So someone says, okay, this is a bad requirement, we have to modify this. This is not what the customer is asking for. Okay, we change that and that's all. But if we move forward without detecting that mistake, that failure, and we go to the design step, and now we discover that mistake, that is going to cost 2 or 3 times that dollar. It's going to cost $2 or $3 to fix that because we have to go back to the requirements and then modify the design. in the codification, if we discover that mistake in the codification step, it's going to cost like $4 or $5 instead of just $1. And as we go further into the project, we can finish in the operation step discovering a mistake or discovering an error in the requirements, and that is going to cost that like 70 times what it costs in the requirements step. Okay, basically now we have put in production this software, or this system is in the market, and now we have discovered that this requirement is wrong. So now we have to go back, and this is going to be a huge failure. Okay, so one thing that we have to take into account is that expending some extra time, some extra money at the beginning of the project with the requirements step is going to, at the end, help us to save thousands and millions of dollars. Here in this slide, we can see a practical example of all this. Let's just picture that we have to design, or we have to build a house for our dog. Okay, so we have been discussing with the person who is going to build this house for our dog. We have been discussing the color, the shape of the house. We want to have a red roof. We want it to be white. It's going to be made of wood, and so on and so on. So we get the final product, and we are really happy with that. But at the end, we discovered that maybe this is not what we asked for. Okay, and this is also really important. Nowadays, when we talk about quality assurance, we are always thinking about testing and test. And of course, tests are a really important part in quality assurance, but they are not the only artifacts to be taken into account. Because in this example, this house probably will be really good. We will be passing all the tests, but at the end we discovered that we were missing one key requirement, which is the size of the house. Okay, so we have to take into account that the Q&A is not only test, but it's also about requirements. And even if we pass the test, that doesn't mean that we are delivering the product or the project that was ordered by the customer. We have to be sure that all the customer requirements were gathered, were in the project, and also we have to be sure that we get all the correct requirements that the customer is asking for. So we must spend some extra time, some extra money in this development phase. Regarding this, we need not only to write down a requirement specification, but to write down a good requirement specification. And regarding that, you can look up at the internet about the characteristics of good requirements. Okay, I have gathered some of them in this slide. For example, the first one that we are going to find is that the requirement must be clear. The requirement description must be clear. Basically, it must be easy to read and easy to understand. If I start writing down something like, the system must do this unless these things happen, in that case, then the system should behave in this other way. But of course, if, and so on and so on, that is not a requirement, of course. That's a novel or a book that I'm writing down. When writing the requirement, we have to be sure that the requirements are clear and easy to read, easy to understand. Also, the requirement must be atomic, meaning that they must specify a single need or characteristic. It must focus on just a single aspect. It's really common that we start writing a requirement and we gather different ideas into the same requirement. The system must do this and also do this other thing. I don't know, the system must manage suppliers, manage providers, and also generate reports. That's cool, but those are two different requirements that we have to take into account and we have to be careful with. Of course, another really key aspect when working with a requirement, they have to be non-ambiguous. Okay, each requirement must have a single and objective interpretation. Something really common is saying that the user interface must be friendly or the system must be easy to use. Okay, good luck testing that. What's the meaning of easy to use or user-friendly? Okay, we have to write the requirement in a way that it can be measurable and it can be easily understandable by all the people that need to work with those requirements. So we have to avoid ambiguous terms. Really related with the previous one, the requirement must be verifiable. Okay, so somehow we must be able to test, demonstrate, analyze, or examine the requirement in order to verify that we have accomplished. The requirement, of course, must also be necessary. We have to be really careful with this because sometimes we are thinking already in the way to solving what the customer is asking for, and we start adding requirements that the customer has not asked for. So we have to be sure that everything that we are putting down into the requirement specification is what the requirement has asked, is what the user has asked for, not additional requirements that are going to unnecessarily limit the solution. The requirement must be design independent. Okay, and this is also really important because if we add design decision to the requirement, we may be concealing real needs. Okay, for example, if we are developing a software and we put in the requirement that we will require a database because the customer asked for a database, if we don't ask why a database, we just put there the database, we may be hiding something. Maybe their database was not required. Maybe the customer is not sure about what is a database and is asking for something that he's not really aware of. So we have to be as much as possible design independent when working the requirements, at least the high-level requirement. Requirements must be also feasible. We have to somehow be sure that we can get that requirement with the current infrastructure, with the current budget, and with the current time. If not, then it's going to be a failure because we won't be able to finish with the specification. The requirement must be correct, and for that, of course, is the user, the one that, or the customer, the one that is going to verify the requirement, but we must be sure that the requirements are correct, especially true for requirements including formulas and calculations. And finally, the requirements must be traceable to other requirements, to test, to the user that asked for the requirement, or to the customer, to maybe use cases, to design, to the codification, and so on and so on. We have to trace the requirement with a lot of artifacts into the project lifecycle, so they have to be traceable. Okay, and this is really related with atomic, because the more atomic a requirement is, it's going to be more easy to trace that requirement. Because if several things are being discussed into a requirement, it's going to be more difficult to trace that requirement. So these are going to be the characteristic of a good requirement, or some of the characteristics of a good requirement. But of course, we also have got a characteristic for a good specification, basically for the set of requirements. The specification must be complete. We mustn't forget requirement. Everything that needs to be implemented must be in the specification. It must be consistent. Of course, if this requirement is saying do this other requirement cannot say do this other thing or on this other way, because then we won't be able to fulfill those two requirements. I don't know, the size of the box is going to be 2 feet, okay, 2 feet, and then another requirement is going to be 3 feet. Okay, we cannot comply with both requirements. The requirement specification must be modifiable because requirements can, and of course they will, change through the project lifecycle. So for that, it's really important to trace the requirement in order to analyze the impact of a change, to have somehow a version mechanism associated with the requirements and things like that. And finally, the requirement specification must be prioritized in order to analyze what is going to be developed first, those with high priority afterward, those with medium or whatever. So those are really important characteristics for a good specification. So we have got a characteristic for a good requirement and characteristic for a good specification. How do we apply all these rules? Okay, different mechanism. First of all, we have to become familiar with all of these rules, so we are going to apply them automatically. Okay. Additionally, also we have to review all the requirement specification with the rules in hand or with the rules in mind, just to be sure that we are compliant with all the characteristic of a good requirement or of a good specification. Okay, but all those things are really difficult to do when you are writing thousands or maybe millions of requirements. So another great thing that we can do is just use a tool that is going to automatically verify that I am fulfilling with this rule. I'm fulfilling this rule. Okay, so for that we can find in the market tool like a Visor Quality Analyzer. The Quality Analyzer is a semantic analysis tool, that is going to, based on certain predefined rules that the user will be able to customize, to tailor in order to fit into the project, we will be able to get some quality metrics of our requirements. Okay, basically the tool is going to tell us the quality of my requirements. But not just that, it's going to also give us some advice, give us some tips in order to improve the quality of my requirements. Okay, so following these tips, following this advice, I will be able to write more requirement with much more quality that will be more easy to understand, more easy to comprehend by everyone that need to work with those requirements. Okay, and additionally, I will be able to generate different reports and different metrics based on the project quality, based on the requirements quality, and so on and so on. Okay, so what we are going to do now is just stop these slides and just move forward to a short demonstration of the tool. Because in this slide, it's really easy to say we have got a tool that is going to help you to understand or to analyze your requirement. So what we are going to do is just open a different machine in here, and I'm going to enter into this requirement to show you an example of a project. And afterward, we will be analyzing the quality of the requirements into this project. So you can see firsthand how the Visor Quality Analyzer is working. Okay, so like I was saying, the first thing I'm going to do is just log in into the tutorial project. Okay, I'm going to use an administrator user. Okay, by using an administrator user, I will be able to just modify everything, change anything I want to change. Okay, there are of course other roles defined into the project, but for this demonstration I will be using the administrator. Okay, and the first thing that I have configured for this user, in this case the administrator, to see is the system requirement specification. In this specification, in this document, we have two subchapters, which are the mechanical requirement and the software requirement. And under each chapter, we can find several requirements, each one of them with a code, with a name, with several attributes, in this case, priority and the status, but we may have as much attributes as we want, as many as we want. And finally, we have got also a description for each requirement. What I'm going to do before explaining all the information in this view is just move to a different view. I'm going to open this diagram in here to show you how I have configured everything. What I'm watching right now is what we call into Visor requirement a block diagram. A block diagram is just the meta model or a graphical representation of the process that I am following into this specific project. Okay, take into account that I have developed this this diagram for this specific project, but we can create a diagram in order to follow our current requirements process. Okay, so in this simple example, I have just created a process in which customer requests enter into my system, enter into Visor requirement. They are created by a specific user, and those customer requests are analyzed, and afterward they are satisfied by means of user requirements. Basically, those user requirements are going to be like a high-level requirement that we are going to write down in order to gather to represent the customer or the user needs. Okay. After that, we are going to analyze all those needs, all those requests, and we are going to write down system requirements that are going to be traced with the user requirements. The system requirements are going to be a proposal or a solution that we are proposing to the user requirements. Okay, basically the user requirements gather some needs, and in the system requirements we are just putting there some alternatives for fulfilling those needs. In this case, the system requirements are classified. You can see here this is a hierarchical relationship into two subtypes: mechanical requirements and software requirements. Finally, I have also defined two levels of tests that are related with the system requirement, the system test, and also with the user requirement, the acceptance test. As I mentioned before, take into account that this diagram is just an example of a process that I have just created for this short demonstration. But we can create the diagram as we want in order to fit into our company process. For example, we may have a more agile-oriented approach with user stories, with sprints, with a product backlog, and so on and so on. We can represent that also using one of those diagrams. And then the tool is going to help us to enforce us to follow that process. Okay? For helping us to follow that process, the tool is going to define different templates for each type of elements that I am defining here. For example, the customer request may have specific fields and specific access rights that are going to be completely different from the one for the user requirements or for the one in the system requirements, and so on. We can also configure the traceability policies, so this element may be traced with this other element, but not with this one, and so on and so on. So once again, following that process that I have just put it in here, we have configured the project to work in this way. So if now I go back to where I were, which is basically here, focusing into the system requirements that are classified into mechanical and software requirement, we have created this Microsoft Word-like view. Okay, so in here, I can analyze the existing requirements, and I can also create new requirements. And that is what I'm going to do. I'm going to create a new mechanical requirement, and afterward, we will be analyzing the quality of that requirement. So you can see exactly how the quality analysis is going to help me to measure, or is also going to help me, giving me some hints and tips to improve the quality of my requirement. Okay? So I'm going to create a new mechanical requirement, which is one of the available templates that you can use for create elements. In this case, I have got mechanical and software requirements. And here, the name of my requirement is going to be, for example, SCU crate, or something like that, which is related with this specific project. Okay, I can specify the priority, and I have also define a template for the description. The system, shall, should, will, and then the action to be performed, whatever. I'm going to delete all this, and I'm going to just write down a requirement as I want. Okay, so I'm going to say that, okay, here we think that the SCU, sorry, I forgot a T, that the SCU crate should be quick, of course, easy to use, why not, and also it's going to be what, and also should not weigh more than 400 pounds, for example. Okay, so this is my requirement, and click on OK, and just as simple as that, I will be creating a new mechanical requirement. As most of you may realize, this is probably a really bad requirement, okay, but let's create it as it is, and let's just wait for the quality analyzer to tell us why this is a bad requirement. Okay, from here I can modify attributes, I can change whatever I need, I can change the status, because there is a workflow associated with the status. I can just put it into the status accepted or approved. Here we go. And also from here, I can just modify different requirements. When working with the requirements into visual requirements, take into account that we are implementing a complete change management system associated with each requirement. So when you enter in here and you start modifying a requirement, you are blocking that requirement for you, but only that requirement. Any other user can enter into the same specification and modify the requirement just next to the one you are modifying, because you won't be blocking the whole document or the whole specification. You're just blocking that requirement that you are working with. Okay, and that is performed through a check-in, check-out mechanism implemented into the tool. But as I mentioned before, this is not a visual requirement webinar, so I won't be focusing into the capabilities of visual requirement. I'm going to close, in fact, visual requirement, and I'm going to open the quality analyzer. And we will be watching how we can analyze the quality of the requirements in my specification, and also specifically about the quality of the requirement that I have just created. Okay, I'm going to connect to the project. Okay, and I'm going to analyze the quality of that. Also, I would like to remember all of you that into the GoToWebinar interface, you have got the question panel, the question tab that you may use for post any question that you may have. At the end of the webinar, I will be answering all of these questions. Okay, we have limited time, so probably I won't be able to answer all of them, but all of those questions that I won't be answering in the webinar, we will be answering all of them through email afterward. Okay, so just please remember that you can post any question that you may have. Okay, so from here I can analyze my requirements, but before that, let's just let's go tab by tab explaining the tool itself. The first tab that I have got here is the quality assurance tab. Here I can define the different metrics available for my different projects. In fact, with the tool, there is a couple of available metrics, available set of metrics, which are the COSI and the TRC ones. Okay, but you can create your own metrics, like I have done here in the RQA demo set. Okay, I'm just going to analyze the list of rules that we can customize into one of those metrics. Okay, as you can see, there is a lot of rules that we can configure, but I won't be analyzing or explaining all of them because we have a limited time. I will be just focusing on the most relevant or some of the most relevant rules that we can customize. Okay, in here we can find the first rule, which is ambiguous sentence. Okay, and the rationale of this rule is that a requirement should not contain any ambiguous concept. I told you before about things like saying that the user interface must be friendly, or that the requirement or the system must be easy to use. That doesn't mean thin, okay? Because for you, maybe friendly means that the colors are the company colors. For me, maybe friendly means that the menus contains as much as 2 levels deep, okay? So we should avoid ambiguous terms. So thanks to this rule, the tool is going to look for what it considers ambiguous. That can be, there is a predefined list of ambiguous things, ambiguous terms, but of course you can modify that list of terms, adding new terms, deleting existing one, and so on. And then it's going to, based on the number of ambiguous terms that the tool is going to find, it's going to give us some metrics. We can specify the different ranges, the different threshold in here. So we can say, okay, I want if it contains between 0 and 1 ambiguous term, it's going to be fine. If it contains 1 or more, it's going to be a bad requirement. Okay, the quality is going to be low. So we can define for each rule this kind of ranges. Afterward, we can also assign a specific weight for each rule. So for example, for me this rule is more important, so I'm going to assign much more weight to this one, 2, 1, whatever. Okay, so I can modify the weight and I can enable or disable the different rules. Connectors, for example, this is a different rules. I have told you also before that usually the requirement must be atomic. Okay, things like and or when I am explaining something into a requirement, the requirement must do this and this, or the requirement must do this thing or this other thing. Usually this means that we are putting together two requirements into one. Okay, so the tool is going to look for connectors, and based on these ranges, is going to tell us the quality of the requirement. More things like, for example, flow sentence. Things like if, else, but, however, things like that are really complicated to follow into a requirement, so we have to try to avoid them. Okay. Imperative mode, we should use the shall. Okay. We shouldn't use must or shall or will. We have to be imperative when writing down requirements. Domain concepts and domain verbs. Okay, that's something that we can also do, is defining a glossary or a vocabulary for the different terms that we are using into the project, and afterward we can enforce that at least that all the requirements contain at least one word coming from that glossary. Okay. More things like and or, I told you about this one before. Pronouns. Usually pronouns are describing or just pointing to someone, but we must use that specific name. He, she, who is he, the user, or this specific role. Okay, so put that, don't put he or she, for example. Okay. Acronym. We shouldn't use acronym if we haven't defined them into the glossary, because some users may not know what we are talking about. Okay. More rules, more things like, for example, the text length in word or in paragraphs. Okay, we have to take into account that we are writing down a requirement, not a book. So we have to try to write a simple sentence, not too long. Okay, so all those kind of things can be configured in here. So we can configure if the rules applies or not, the weight for each rule, and the different ranges, different threshold for each rule. Okay, and based on that, we will define our metric, our set of metrics. Here we have got also the knowledge management, which allow us to define or to specify those special sentences that we have been discussing before. So, for example, what is an ambiguous sentence? A few, a lot, about, adequate, all, ancillary, enough, friendly, easy, whatever. Okay, so we can add or remove existing word from this vocabulary, and then we will be using that for analyzing the requirements. So we have defined here what is an ambiguous sentence. We have defined here what is a connector, and, or, whatever, however, meanwhile, otherwise, whether, so on and so on. Okay, so from here we can specify the different sentence. We can also specify the default magnitudes and different system that we are going to use for measuring my requirements. For example, if we are talking about distance, we may be measuring in kilometers or maybe in miles. Okay, both are fine, but we must try to use only one of those, because it could be complicated to translate from one to another. So the tool is going to also help us to look for different measure units. Okay, so we are talking in this requirement about pounds, and in this requirement about kilograms. It's going to tell us, okay, you should use just the metric system or the British imperial system, but not both. Okay, and also here we can find the glossary I told you about before. In the project configuration section, we can define the different metrics that we are going to apply for each block. Okay, because we can define a specific metrics for each specific block, maybe one for the user requirement, maybe one different one for the system requirements, and so on and so on. And finally, in the quality control, we can analyze the quality of my requirements. In fact, you can see here that we have already analyzed the quality of the requirements into my project, except for the first one, which is the requirement that I have just created a moment ago. Okay, so what we are going to do here is just analyze the quality of this specific requirement. We are going to ask for the tool to just, based on the metrics that I have defined at the beginning of the webinar, that I have explained at the beginning of the presentation, we will be getting some quality metrics for this specific requirement. And here they are. Okay. The first things that we can find is that we are using ambiguous sentence in the requirement. Quick and easy to use. What is quick? Maybe for you quick is 2 seconds. Maybe for me quick is 1 nanosecond. I don't know. We have to specify what is quick. Easy to use. Once again, that doesn't mean anything. It's ambiguous. A conditional mode. I have used should and should here also, where I should be using shall, okay, for writing down the requirement. I am using also generic terms. Use. When it's specifically what kind of use? Okay, because use means read, use means write, use means that I'm going to pick it and do what with it. Explain that, because use doesn't mean anything. It's too generic. Okay. Incorrect spelling. I have write down here a word that is not recognized, SCU, and it's also here in the acronym rule, because I am using SCU and I haven't defined anywhere what is an SCU. Okay. Measurable, easy to use. Easy to use is not something that I can measure. Okay. So once again, basically I have get this all these rules, pronouns. We, think, that, we. Who are we? I haven't specified who is we. Okay, so this is a really bad requirement. In fact, it's just having 1 star out of 3. Okay, it can contain 0 stars. Okay, this was done on purpose, of course, just for illustrating, for showing all of you how we can measure the quality of the requirement, but it's just a good example of what we can get. Not only this kind of metrics may be applied, because those are metrics for specific requirements, but we can also apply metrics for the whole set of requirements. I told you before about the unique conflicts, which can be analyzed. Just look for requirements that are into the metric system and into the empirical system or different measure system. Okay, but there is also another thing that we can do with the whole specification, and it's looking for overlapping requirements. Okay, when looking for overlapping, the tool is going to analyze the description of each single requirement, and it's going to compare that description with all the requirements that we specify. For example, I'm going to compare all the system requirement with all the system requirement, and I'm going to get these metrics in here. So, for example, I have got here almost a 100% similarity between these two requirements. Okay, the first one states the mobile car shall be capable of rolling over standard doorway threshold, and the second one stands the mobile car shall be capable of rolling up standard track elevator tailgates. They are not exactly the same, but they are really close. So the tool is telling me, okay, you can do as you wish, but you should focus into these two requirements because they look really similar. They may be overlapping. It may be some conflicts between these two requirements. Okay. Another example in here, this one. Well, in fact, these two requirements contain exactly the same description. So in this case, for example, I have write two requirements with this exactly the same description. So that's something that I have to, one of them should be removed. Okay, so this is really helpful because in this case I have got like 40 requirements, something like that. But in a real project with thousands of requirements, hundreds of thousands of requirements, it's not going to be so easy to look for requirements that are talking about the same subject or that are exactly the same or that are in conflict. But the tool is going to help me to by pointing to those requirements. Okay, it's going to tell me, look to this couple of requirements because they look really similar. They may be the same, they may be not the same, but you have to analyze them. So it's going to be really helpful telling me exactly in which requirement I must focus. Okay. And finally, another thing that I can accomplish from here is the possibility to just modify the requirement on the fly and just get new metric as long as you start working with the requirement. Okay, so for example, if I remove the word SEU, okay, that it doesn't make sense now, okay, but I don't know, I think that the create SEU create system create, for example. Now there is no problem with the chronism, okay, and now there is no wrong spelling. Okay, so I can start modifying the requirements on the fly and analyzing how I can improve my requirement based on these tips in here. Okay, and I can easily afterward save those requirements back into this requirement. Okay, I can recalculate the quality with different changes and just afterward save everything I have modified to this requirement. And I'm going to close this. And finally, we can of course get different metrics for each specific user, also different graphs with the quality of the requirements that we are writing into my project. For example, in this case, we can see that this user has written 4 high-level requirements for high quality requirements, 2 medium quality requirements, and 27 low quality requirements, things like that. We can just get different metrics, different reports, different graphs with the project status based on the quality of those requirements. Okay. So I'm going back to the presentation, to the slide, and I'm going to just summarize what we have been watching today. Basically, we have seen that the quality analyzer, the visual quality analyzer, can help us to answer all of these questions. Are your requirements over-specified? Because we can create the rule for defining the design sentence that we mustn't find into the requirements. Do you express several needs into the same requirements? By looking to connectors like and or, that is going to be really easy to find. Are you using fuzzy or ambiguous sentence? Are you using negations, acronym? All those things can be easily analyzed through the quality analyzer. And afterward, the tool is going to point to those requirements that need to be modified or need to be correct. Okay, so at the end, it's going to really help us to save a lot of time writing high-level requirement, and it's going to help us also to teach our final users to write the requirements in the way we have configured the tool to do that. Okay, so we want our user to write the requirement in this way. We can configure the tool, helping the user, teaching the user to do that. And that's all that I wanted to share with you today through this presentation, through this webinar, and through this demonstration of the Quality Analyzer tool. As I mentioned before, I remember all of you that we have got the question tab, the question panel into the GoToWebinar interface that you can use to pose any question that I will be solving into just a few seconds. Before that, I'm going to stop recording the webinar now because we don't want to put all the questions also into the webinar. So goodbye for everyone who is watching this recorded webinar.